Okay, so for this video, right, this result or all three results here are super important, okay, for the double angle of cos. So cos 2a is cos squared a minus sine squared a. That's the first one we learn, and then these two are just variations of this one, okay, but it's these two that are always the important ones, okay, and we're going to utilize these today. So in order to integrate, for instance, cos squared x dx, okay, we could be asked to integrate that there, the square of cos, and we haven't done that before. So how do you go about it? Well, we're going to utilize this idea here, okay, and we're going to use the middle one, the middle result, because it's got cos squared in there. Okay, so let's rewrite it then. So cos 2a is equal to this, but let's put it in terms of x, because we've got x there. So cos 2x is equal to 2 cos squared x minus 1. Okay, so we just need to rearrange it then to get cos squared x equals. So let's take that minus 1 over, become a plus 1, and that equals to 2 cos squared x. Okay, but I need cos squared x, so I need to get rid of this 2 now. So if I divide through by 2, okay, then divide this by 2, that's just going to become a half, isn't it, of cos 2x. Divide this by 2, it just becomes a half, and divide this by 2, I get cos squared x. So that's what cos squared x is equal to, okay, half cos 2x plus half, okay, and I could even factorize out a half and write it like that, okay. And what's good about that is now I can integrate cos squared x dx using this instead, okay, so replacing it, and the reason why it's useful is because this is quite easy to integrate, okay. So the integral of cos squared x dx becomes, well, if I replace it with this, okay, well, there's a half there in front, constant half, so you can put that outside the integral, and you just got to integrate that with respect to x. And it's really easy. It goes back to the integration work we've done before. Okay, you just got to think what happens to cos when you integrate it. Cos becomes sine, yeah? And because it's cos 2x, it'll become sine 2x over 2, yeah? We obviously divide, don't we, when it comes to integration, because it's the opposite of differentiation. So we divide by the derivative in there, right? Okay, so 2, the number in front of the x there. And then, of course, 1 is a constant. Integrate with respect to x, you get x, and plus c. So there's our result, right? It's really easy for the integral of cos squared x when you use this rearrangement here. Okay. Now we need to know how to integrate sine squared x as well. Okay. But you know what? It's going to be exactly the same approach, okay, but this time of course we're going to use the third result here. So cos 2a is 1 minus 2 sine squared a. So in other words, cos 2x is 1 minus 2 sine squared x. Okay, so from there you can rearrange this, that minus 2 sine squared x, take it over, it becomes plus 1, then minus, take that cos 2x over. So we're just rearranging these, just swapping them, that's all I'm doing, yeah. Take the 2 over, I'll divide by 2, and we get, what do we get? Well, we get a half minus a half cos 2x, okay? Or in other words, half bracket 1 minus cos 2x. So the integral of sine squared x dx is really easy. You just put the half outside, and you just got to integrate that, 1 minus cos 2x dx. Well, 1 just becomes x. Cos, when you integrate it, becomes sine. So minus cos becomes minus sine of 2x upon 2 plus your constant. So there is the result for the integral of sine squared x.